Hello, sir. Here is my working binary game. Here, sir, we have a list of all the parts of this build, but the most notable new part of this build is the Nano. The Nano is a very important piece of the puzzle as it allows us to send or write digital signals, that being a high or a low, and receive digital signals, a high or a low. In this build, we are receiving digital signals, high or low, when the Nano is looking at the switch bank. If the switch bank is turned on or giving a high, the Nano interprets that and responds accordingly. If it's giving a low, it responds accordingly again. At the same time, the Nano gives a digital signal when it gives the signal to the 595 chip to be able to function the Moreland bar graph. Here, sir, we can see the combination of all the parts, including the Nano and the 595. Now, as you can see, it's showing 128 because we know the Nano is monitoring the state of the switch bank at all times. And right now, the Nano is picking up that this bit here has a 1 on it. But the question is, why doesn't 1 show here and 1 show here? Well, that's because in the code, I took value, or this bit in particular, and moved it 7 bits to the left, which equals 128. Now, let's say turn on this bit. Now, we can see that 1 is here and 1 is here, because if we look over at this value here, we know that it's not moved, the bit's not moved to the left at all, so it just equals 1. Now, let's turn on 2 at a time. Oh, look at that, 129. That happens because we have this bit on and this bit on. Now, all the bits in the middle are equal 0, so we can just ignore those for now. And what is happening in the code is that I've used the OR function to add the bits together. So the 1 over the 0 is added, all the zeros are in the middle, or just left as zeros, and the 1 over the 0 at the end is added, giving us 129 over here, and our value there.